Okay, ladies and gentlemen, for math today, you're going to need your math notebook, math workbook, and a pencil with an eraser. This lesson is called Lesson 2-7, Properties and Strategies. Please take a minute right now to pause the presentation and write the title of the lesson into your math notebook. The learning target today is, I will be able to use the commutative, associative, and distributive properties to solve problems in my head. Please pause the presentation and take a minute to write the learning target underneath the title of this lesson. Before we go much further, you need to understand what the word property means. Property is simply a math rule. Properties in math can help us to compute mentally with large numbers, fractions, and decimals. All that means is that a property is a rule that is always true in math, and it can help us to solve problems easier in our head. Here's an example of a problem that uses large numbers. 50,000 plus 25,000 plus 38,000 plus 75,000 plus 50,000. I could solve this traditionally, but that might take me some time, so instead I'm going to look for what I call friendly sums. I see a couple of friendly sums in this problem. First, I see 50,000 plus 50,000. I know that 50 plus 50 is 100, so now we'd have 100,000. I also see 25,000 plus 75,000. I know that 25 plus 75 is also 100, so that would equal 100,000. Now I've got 100,000 plus 100,000 and this 38,000 that's left over. 100,000 plus 100,000 is 200,000. And when I add 38,000 to that, I can do that in my head. I'm only writing this out so you can see what I'm thinking. But 200,000 plus 38,000 is just like 200 plus 38, or 238, and then the 1,000 on the end. Why is it okay to do this? There are certain math properties that tell us that it's okay to change the order or to regroup the numbers to solve addition and multiplication problems. The first property is called the commutative property of addition. It says that we can change the order of the addends without changing the sum. Here's the example. 5 plus 2 is the same thing or equal to 2 plus 5. We've flipped the order of the addends 5 and 2, but for both examples we would still get the answer of 7. So we can use the generalization, which is just a general rule that will always work, that A plus B is equal to B plus A. The commutative property also works for multiplication. It says the same thing, except now we're talking about factors instead of addends, and it's the product that doesn't change. Here's an example. 5 times 2 is equal to 2 times 5. We've flipped the order of the addends, but both of those expressions would still give us the answer of 10. So we can come up with the generalization, A times B is equal to B times A. Besides flipping the order, we can also regroup addends to help us solve mentally for math. This is called the associative property of addition. So here's an example. If we had 5 plus 2 in parentheses, which means we were supposed to solve 5 plus 2 first, and then add another 2, we could change it if we found that adding 2 plus 2 first would be easier. The order of the addends is the same, 5, 2, 2. Over here, 5, 2, 2. So the order didn't change, but what we added first changed. So we show that using parentheses. Here, if we add first 5 plus 2, we get 7, plus another 2 is 9. Over here, since 2 plus 2 is in parentheses, we would add that first and get 4, add that to 5, we still get 9. So there's a generalization, and we show that using variables a, b, and c. If we add a plus b first and then add c, we would get the exact same answer if we added b plus c first and then added a. This works because all of the operations involved are addition. You cannot use this property if they're not all addition, or as you'll see on the next slide, all multiplication. So here, the associative property also works with multiplication. You can regroup the factors without changing the product. Here's the example. If we have the numbers 5 times 2 times 2, we could first multiply 5 times 2, to get 10, and then multiply it by another 2 to get 20. Or if we prefer, if we think that multiplying 2 times 2 first would be easier to get 4, then times 5, we would still get 20. So we can come up with the generalization that's just like the one for addition, except we're using multiplication. So try these examples to see if you're understanding how to use the commutative and associative properties to find friendly sums for mental math. This example gives us decimals. What you're looking for here are friendly sums, numbers that when we get the answer it would be easier to continue to add. I see 5/10 plus 5/10. I know 5/10 plus 5/10 would give us 10/10, which is the same as 1 whole. 25 hundredths plus 75 hundredths, I'm just thinking of money here, I know that that would give us also 1 whole. So in the end, we end up with 1 plus 1 plus 38 hundredths. Whole numbers just get added to the decimal portion for a total of 2 and 38 hundredths. One more. This one involves fractions. Again, you're looking for the friendly sums. Here we see 2 and 4/5, and it only takes 1 more fifth to get to the next whole. So 2 and 4/5 plus 1/5 would be 3. 3/4 plus 1/4 is 4/4 or 1. Now we have 3 plus 1 plus 5/17. If we add the whole numbers, we end up with 4 plus 5/17, and as we learned in the last lesson, adding a whole number to a mixed number, you just put them together, or a whole number to a fraction, you just put them together to get the mixed number. Try some more problems like this using the workbook page 47, numbers 1 through 7.